once you take it off, you're gonna use a pipette and drip raspberry juice from the outside edges going towards the middle. Once it is fully covered, you're going to fully dunk it in the rest of the raspberry juice and leave it there overnight. And once you come back the next day, you're going to use a pipette again, and you're going to use vinegar as your electrolyte and put it between those layers. After you completed that, you use the paper clips, or you could use binder clips to hold it in place. And you might be thinking, because it's metal, it's not going to work, right? But it does, because the metal isn't touching the conductive side. It's only touching the outer. And so you test it the next time. And so what happens is, when you're dyeing it, the titanium dioxide with the dye helps to help absorb the light. And then so the electrolyte or the vinegar that you use is going to help to transport the electrons. And then so basically the main process of the project was to design or research, create, test, calculate, and to report on our findings. So when we're researching, we went online and we looked at many tutorials, videos, and websites that we could look to follow this process. And then for the designing, we looked at their tutorials, how they designed it, and we kind of mimicked what they did. And same with the building. We create our own steps, so when we did it, it was easier to follow. And then when we were testing, we set it up exactly the same way how they did it. And for the calculations after it was done, it needed to be accurate. So the problem was that all of these different types of solar cells are different sizes, so we needed to calculate it in order for it to be more accurate. So for us to do that, we practically just tested the whole thing first, and we took the readings off of that divided by its total area, and that gives you the amount of milliamps per each centimeter squared, and then you take that number times 50, because that's the amount or area that we wanted, and then so that would give you a result. So these are the first readings, and after we calculated, this is what we got. So we did 3 trials, and we did one at 5 centimeters, one at 10, and one at 50. So overall, the polycrystalline was the best one. The only thing that we never really got to do was the dye sensitize. Although it didn't really work with the amp meter, it worked with the multimeter, because the thing was that it had the amount of volts, but the current wasn't strong enough. So the reading on that for 30,000 lux, so we use sunlight so it's stronger, so we get more of a reading. The result was 0.23 volts, so meaning that the polycrystalline was still much stronger, and still yet we never really got to do our original design, so that must have been another one of the problems. And so throughout the process, every project goes through problems, challenges, and successes. So one of ours was like with the materials, we needed to order them, so we didn't know if it was going to be on time or not. So it didn't come on time as like planned. And another problem that we ran into was that the dye sensitized wouldn't dry properly. It didn't smooth. There was cracking on the surface, and the dye didn't settle properly, and the cell didn't function as first. So practically we had to redo our solar cell about 5 times just to get it to look like that. And so what we did was we improvised. So we worked on the design and the setup So when the materials got there, we knew exactly what to do and how to set it up and what to use and where to put it. And then, so for the dye sensitized one, for the cracking, we made the layer a little bit thicker and we let it sit for a little less time, so it was still a little bit moist. And then we used a ruler or a pen to even out the surface, unlike how the videos used it with a glass rod, because we did not have that. And then so what we did was when we fully dunked it, the problem was it used to crack on the surface like how you see right here. So instead of fully dunking it in the beginning, we just put the raspberry juice from the outside going towards the middle. And then once that was fully covered, we just dunked it and left it overnight to get a nice clean paste. And so if we were, you might be thinking that, oh, this project doesn't involve any English or history, it only does math and science. But the thing is, it covers all of the 4 core concepts. So English is used in our website, as you see right here, because we had to come up with summaries and we use notes and bullet points to explain how the process works. And we have sections for the how to dye sensitize, the different types, the process, and the results. And then so history took another main part of it, as much as the math and science, because we found out that over time the solar cells have changed. So in the beginning, in 1887, Heinrich Hertz discovered the photoelectric effect by sending ultraviolet light onto metal, and it caused sparks. And in 1905, the process, or how it happened, was explained by Albert Einstein. So another thing that we learned is that in the 1970s, solar panels were silicon-based, the 1980s was thin film, and the 1990s was dye sensitized. Dye sensitized was later towards the future because they are supposed to be it's not supposed to be as expensive, yet it's still supposed to be efficient. And so for the next semester, we are planning to continue or if we do plan to continue, we are going to make the dye sensitized function to its fullest potential. And we're going to update the website with new pictures and answer questions if anyone has any. And then we're going to create a larger model of our choice. And then if we get far enough into the project, we're going to try and find a sustainable company to work with them and help build panels for them maybe and get a budget. And so this is kind of like a diagram as well, because you have the sun and the solar panel and the photons. And so with time like this is what you can create. With time like this is what we can create. We are the students of the future. Thank you.